To end our lesson on differentiation, we're going to do two types of example problems. The first of which is everyone's favorite, related rates. Really don't freak out about related rates. They're not as hard as you think. And we'll see that when we do an example together. So we'll look at oil radiating outward in a circular film on the surface of the water. And we know that the radius of the circle is increasing at a rate of 2 meters per second. And we're trying to figure out how fast the area of the film is growing when the radius is 100 meters. So let's break all that down. Oil is radiating outward in a circular film. We're going to be working with a circle on the surface of the water. The radius of the circle is increasing at a rate of 2 meters per second. If the radius is increasing at a rate, we have a rate of change of the radius. I'm going to say that that is dr dt. We know dr dt is a constant 2 meters per second. I'm trying to figure out how fast is the area of the film growing. I'm trying to figure out dA dt. And again, dA dt is probably not going to be constant, which is why I'm given a time when r equals 100, when the radius equals 100. So this is sort of the rates that I'm given. I'm trying to figure out how they're related. Before I can get how my rates are related, I just need a way that radius and area are related in just in general, not their rates. And I know that because this is a circle, area equals pi r squared. That's how radius and area are related. Now I just need to figure out how their rates of change are related, and I can get that by differentiating both sides of the equation with respect to time. The derivative of a with respect to time is dA dt. The derivative of pi r squared, that r squared is my variable, its derivative is 2 pi r, but because I treated r like my variable, I need to multiply by dr dt. And now all I have to do is evaluate that when r is 100. So I get 2 pi times 100 for r, and I know dr dt is 2. That turns into 400 pi. This is in meters, 100 is in meters. This is in meters per second. So this is going to be meters squared per second, which makes sense because meter squared gives you area. We're trying to find the rate of change of the area. Hopefully that showed you related rates are not super difficult, and the ones on your final exam are just as easy as this. The next type of application problem that's going to be on your exam that relates to differentiation is position, velocity, and acceleration. Remember, velocity is rate of change of position, and acceleration is rate of change of velocity. So velocity is the derivative of position, acceleration is the derivative of velocity. For example, if the velocity of a particle is modeled by v of t equals t cubed, what is the acceleration of the particle at t equals 4? Well, if we know velocity is t cubed, to find acceleration at a given time, we can differentiate and get 3t squared. And then a of 4 equals 3 times 16, 48. There are no units on this problem. If there were, say velocity was in meters per second, acceleration would be meters per second, for meters per second squared. Another example, the position of a particle is given by the function x of t equals t cubed plus sine t divided by the square root of t plus 7. And I want to know what is the acceleration of the particle at t equals 4. Actually, I lied. I want to find out. Sorry to make so many mistakes today. I just want to find out what is the the velocity of the particle. What is the velocity of the particle at t equals 4? To go from position to velocity, we need to differentiate. To differentiate that function, you would have to do some pretty messy quotient rule, which doesn't sound super appealing to me. And I'm telling you now that a function that looked like this would be on the calculator active portion of your exam. So let's practice using our calculator. I think that we as a class are pretty comfortable integrating using Math 9, but don't forget that you can differentiate using Math 8. So I actually want you to do this. Grab your calculator, and in your calculator, you're going to go to Math 8. And we're going to differentiate. Here our function is in terms of t, but let's just use x. So differentiate with respect to x. You can type in that entire function. It might be helpful to use alpha y equals to get that fraction bar. I'm going to type in x cubed plus sine x on top and root x plus 7 on the bottom. And then over after the evaluation bar, I'm going to type in 4 because I want to evaluate it when my independent variable equals 4. And so we can get that the velocity at times 4 is 5.066. Again, whatever units there are. But we can do all that work of differentiating and plugging in that point using Math 9. Definitely a skill that you're going to need for your final exam.